pressure is nothing other than force per unit area. And so when we think of pressure, there are a couple of ways, I mean, a couple of things you think about. Here in this illustration, you can use the same force with poking somebody with your finger that you do with a needle, but the pressure from your finger is way less because even though it's the same force, the area of your fingertip is much larger than the area of the end of a needle. And so one of these doesn't penetrate the skin, the other does. So that is you know, it's our first illustration of pressure is force per unit area. Unit of pressure are pascals. Well, what's a force? Force is newtons. Area is square meters. So 1 pascal is 1 Newton per square meter. If you wanted to convert that to PSI or pounds per square inch, 6,895 pascals is 1 pound per square inch. And if you want to convert it to atmosphere, you can see a pascal is a very small unit compared to an atmosphere, 101,325 pascals. And if you want to convert it to millimeters of mercury, I think it's like 700 millimeters of mercury, somewhere in that area is uh, a well, that's 1 atmosphere. So um, if we look at a fluid, which is what this is about, um, the fluid density determines pressure at depth, right? And so you've got atmospheric pressure at the top here. So at the very top, you have whatever your atmospheric pressure is. But when you go down lower in the fluid, down in here, well, now you've got that plus the weight of whatever fluid is sitting on top of you over that area. And so when you look at fluid at depth, the pressure due to the fluid itself, not the atmosphere. We're going to ignore the atmosphere for now. The pressure due to just the weight of the fluid, right? Force per unit area. The force is the weight, mg. Well, m is rho, your density times your volume. All right, so your density times your volume. Um, And then when you look at what is your volume, well, and here we have a regular cylinder, so we don't worry about the change in shape. So the volume is that area times whatever height you have. And the area gets canceled out, regular cylinder. And so rho GH is your pressure um, at depth in the water. And so if we look at water, are in the fluid. If you look at water, it's 1,000 kilograms per cubic meter, and we go down to 10 meters. Well, we're at 98,000 pascals. We're almost 1 atmosphere. So every 10 meters you descend to in water adds an atmosphere of pressure, um, which is why submarines have to be built the way they do, because to go down to a few hundred meters, you have to be able to withstand lots and lots and lots of atmospheres of pressure. So that's it for pressure, and we'll see where that plays out in other parts of what we're going to do and throughout this section and the next.